Hello everyone, I am Professor Amit Solanki. Today we will discuss the topic that is the construction of SCR, or we can say that the construction of thyristor. As you know that there are switches, the thyristor is working as a switches. So first we'll discuss the classification of switches. On the basis of blocking, that is the first unipolar switch, are those switches which can block only one polarity of voltage. For example, diode, it will conduct when anode voltage is greater than the cathode voltage. Then current is not equal to 0. In that case, when anode voltage is less than cathode voltage, it blocks the reverse voltage. That means reverse voltage. In that time, current is 0 and voltage is not 0. Okay, so that means it can allow the current flow in only one direction. So this is the type of unipolar. Now, second one, that is a bipolar switch. Bipolar switch, that means it is a switch which can block both polarity of voltage like SCR. That means SCR thyristor is work as a bipolar switch. Then anode to cathode voltage is greater than 0. In that gate current is 0. That is a block positive voltage. And when anode to cathode voltage is less than 0, at that time it will block the negative voltage. So this is the classification of bipolar switch, and thyristor is an example of bipolar switch. And on the basis of current flow, the switches are defined in unidirectional switch and bidirectional switch. The unidirectional switch, that means which allow the flow of current in only one direction. For example, SCR, GTO, and diode. These are the examples of the unidirectional switch. Second one is that is a bidirectional switch, which allow to flow of current in both directions. For example, the triac. So for positive voltage, VAK is greater than 0, and for negative, VAK is less than 0. So this is all about the bidirectional switch. So triac is the example of the bidirectional switch. So these are the basic concepts regarding the switches, different type of switches category. Now we are discuss about the construction of the thyristor, or we can say that the construction of the SCR. So in that case, we are starting from the basics of the thyristor. The name thyristor is derived by a combination of the two capital letters from thyratron and transistor. This means that thyristor is a solid state device like a transistor. So in that figure, you can see here the physical view of the thyristor. In that, you can also see here that is the N type, P type, N type, P type. These are the 4 layer, okay, and 3 terminal device. The SCR is a 3 terminal device which is anode, cathode, and gate, as shown in this figure. And SCR has built-in feature to turn on or turn off, and its switching is controlled by biasing conditions and gate input terminal. So in that you can see here, this is the symbol of SCR, in which you can see here the 3 terminals, anode, cathode, and gate. So this is the symbol for SCR. In that symbol you can see here there are 3 terminals, anode, cathode, and gate. Now the SCR is a 4-layer and 3 terminal device. The 4 layers made up of P and N layers and are arranged alternately such that they are form the 3 junctions, that is J1, J2, and J3. So generally, according to the construction of the SCR has 4 layer and 3 terminal device. 4 layer, that means PN, and 3 terminal, that is the anode, cathode, and gate. The 4 layers made up of P and N layers are arranged until such that they form 3 junctions. These junctions are either alloyed or diffuse based on the type of the construction. So according to that, you can see here in this structure, there is the 4 layer PN alternately, and there are 3 junctions. This is the J1, J2, and J3. And there are 3 terminals: anode, cathode, and gate. This is the structure layer of the thyristor. Now, if we are talking about the detailed construction of the thyristor, so accordingly that, as we know that there are 4 layers, in that outer 2 layers, that is the P and N, are heavily doped, whereas middle 2 layers, P and N, are lightly doped. And the gate terminal is taken at the middle P layer, and anode is from outer P layer, and cathode is from N layer terminal. This is about the structure of the thyristor. And SCR is made up of silicon because compared to germanium, the leakage current in silicon is very small. So for that we are prefer silicon as compared to germanium. So as you already seen in this figure, now we are discussing about the advantages of the SCR. The SCR, it is a compact in size. First advantages of the SCR. There are many more advantages, but we are discussing here some few advantages. Second one is that is it possesses high reliability. That means this device is very high reliability. Third one is it have very low losses. That means thyristor have very low losses. So for that it is used mostly. So these are the all about the concept for the construction of the thyristor. In that we can conclude that the thyristor have 4 layer P-junction and 3 terminal devices, where terminal name is anode, cathode, and gate, and junction, that is the J1, J2, and J3. And 4 layer are, that is the P and PN. So these are the all about the concept for the thyristor construction. Thank you so much.